Assalamualaikum and a very good day. Okay, we continue our discussion with convolutional neural network. I believe that everybody already clear about the convolutional process, the fundamental behind the convolutional process. Start from the one-dimensional signal to two-dimensional signal, and then of course we highlight more on two-dimensional convolutional operation, and again in CNN or convolutional network, you will find that uh, you find that the convolutional operation involved in CNN is more to two-dimensional, and it can go up into three-dimensional convolutional operation. So of course I just forget that I also include the slide, okay, because in previous lecture I show you the slide from the image processing courses, but actually I include in this material, which is this one. Okay, so this one is a two-dimensional convolutional process. So meaning that what is the meaning by two-dimensional? Because the input here is a two-dimensional input, so that's why the convolutional operation is called a two-dimensional convolutional operation. Okay, so you slide into the entire image, but again, don't confuse with the CNN, because CNN also involved with three-dimensional convolution. Because if you okay, that's why if you see over here, okay, actually this one is also can represent in three-dimensional, because you will find out this is what is the size of the matrix. It should be, for example, this one. Okay, this one is 4 times 4 matrix. Okay, because normally this is your y size, this is your x size. Okay, because why we start with y? Because normally in matrix we also always mention the row first before the column. So this is the row, this is the column. Okay, but how about, let's say, if you want to represent this matrix in three-dimensional form, so how to represent it? So it can be something like this, which is 4 times 4 times 1, which is, this is your y axis, this is your z axis, this is your x axis, and this is your z. So because since your z is actually you only have one layer, or you only have a one layer, or the depth is equal to, sometimes we call it as a depth. Okay, the depth is equal to 1, so that's why we can still consider it as a two-dimensional signal. Okay, but of course later you will find out the depth is not always 1, it can be more than 1. So that's why you need to have the where actually you need to in order to compute that kind of matrix, in order to execute the convolutional, then that is what we call as a three-dimensional convolutional operation, because it involves three-dimensional matrix or three-dimensional signals there. Okay, of course sometime in image processing book they call this also as a channel. Okay, you can call depth, you can call channel, but in channel, but in these courses I will not call it as a channel. Okay, because I find out in AI course they use the term channel for other things. Okay, that's why we cannot use the term channels. Okay, you can find out in these examples there. Yep, this one. Okay, this actually this picture is taken from image processing book. That's why they call this one as a single channel. This kind of image, doesn't matter is it a grayscale or black and white, you call it a single channel, because the depth there is equal to the depth, or the z there is equal to 1. Okay, you have the numbers of x there, this is your X size. Okay, this is your X size, and this is your Y size, but the depth which is going into that direction is only equal to 1 because you only have one layer there. So that's why, because you have one layer, they call it a single channel, while for color image it call it multi-channel because the Z there is more than 1, or the depth there is more than 1, which is in this case your Z or your depth there is equal to 3 because you have R, G and B. So that's why you have if you are going to that direction, Z direction, then you have a 3 value there, which is more than 1. So that's why they call it multi-channel. But in artificial in this class, please don't use the word channel. Okay, don't use the word channel because this one I taken from image processing book. They use the word channel because in this course they reserve the word channel for other things. Actually, in this in CNN, they will use the word depth for this one. This Z is also called as a depth, but is not equal to channel. Okay, because the word channel normally they use at the filter there. Remember, when you want to do the convolution, you have the filter, which is this one. Okay, this is your filter. Sorry, yeah, this one. So normally you are not just using one filter, you are using more than one filter. So let's say you in order to implement the convolutional process, you're not just using this single filter, you have more than one filter. Let's say you have 5 filter where the size is equal like this one, 3 times 3. So the number, let's say the number of filter you are using is equal to 5. So the 5 here, or the number of filter here, is also known as a channel. So if your channel is equal to 5, that's mean the number of filter is equal to 5, or in other words, the filter channel is equal to 5, meaning that you have a 5 filter. Means that each channel you execute once, you execute with one convolutional operation, then second filter you also apply the convolutional, so you will do it in 5 times because you have 5 filters. So that is the meaning by now the word channel is reserved for this thing. So that's why we cannot use the word channel for this thing. Okay, because this one is taken from the image processing book. So please just don't confuse it, because of course you have a different courses, they use a different vocab to name their items. So that's why of course just to remind you that channel in image processing book is not same as CNN, because CNN use channel for filter, but let's use the depth, because depth is image processing also call this one depth, and CNN also use the word depth as refer to Z-axis. So that's just to make sure that you clear about that one. Okay, so now let's go back to what happened at the convolutional layer. So again, this is your image. Of course, this one is color image. So how do I know this is color image? Because the depth is equal to 3. So meaning that you have R, G and B. Of course, normally when you capture image by using your phone camera or your camera, you always get a color image. So so that's why in most of the example here we are using a color image. Okay, but it's not you don't just limit yourself, or don't set yourself that the CNN can just apply for color image. Actually, you can also apply for grayscale image or binary image, but because we always dealing with the color image in real life, so that's why most of the CNN architecture, even the well-known architecture, they are designed for color image. Okay, so and then the size of X and Y is the width, and the length there is a 32 times 32 pixels. Okay, with color image. So again, for those who don't take image processing class, so this is how it's look like for color image. 32, you just assume this is 32 times 32 times 3. So 3 there is the depth, or the represent the R, G and B value. So, and the value there in general is a 8-bit. So each element inside this matrix can have from 0 to 255 the value. So because this is a 8-bit unsigned integer. Okay, so let's say this is your filter. In general, the filter, let's say you set your filter size is 5 times 5. Okay, in general, the depth size of your filter, or the depth size of your filter, which is this one, will always by default follow the depth size of your image. If your depth size of your image is 3, then this one become 3 automatically, because I never see people modify this one. Even I also have attend some short courses in deep learning, and I ask about this same things to the speaker, and he said that normally people will not adjust this one. Okay, by default, if you have the size of depth, the depth size of your input is 3, then your filters size depth is also 3. Must follow this one. The one that you can vary is this one, which is your Y size and your X size. Okay, you can go which any value that you want. 5 times 5, 3 times 3, 9 times 9. Okay, that you can vary that one. Okay, but this one will follow this depth size. Okay, means the depth size of the input, the filter depth size must follow the depth size of the input. Okay, so if you do convolution between this 5 times 5, okay, I just said 5 times 5, I just ignore this 3 because this one is always similar with this one. If you have 5 times 5 filter, you convolve with 32 times 32. Okay, that is the explanation there. Filter always extend the full depth of the input volumes. Okay, again, this is what we do during the convolution. We are sliding the filter to the entire image, and then you will get the points there. So this is this is very common start since we learn the artificial neural network or shallow neural network. But now the difference is just the convolution only taken the one which overlap with the filter. The value of your X which overlap with your filter will multiply with your W there. So you are not involved in multiplying the X value which is not overlap with this thing. So of course you must ignore the bias there if you consider the bias. But if you don't consider bias, then you just can cancel this one. But in this node, we don't ignore the bias, so that's why we plus B there. So you can see that to get this one number, the result of taking that dot product between this filter is a small 5 times 5.3 chunk of image. Okay, again, this because this is 5 times 5.3, so you have 75 dimension dot product plus bias. Okay, again, don't forget we have a this one is now not a 2-dimensional convolution, it's a 3D. So that's why you have also not 5 times 5, is also 5 times 3. because you have 5 times 5 times 3 W multiply with 5 times 5 times 3 X that overlap in this window, and then you plus B. Of course B is here. Okay, if you draw the network, the B is here. Okay, this is your B, this is you don't ignore the B, that's why there's 1 there. So let's say you proceed all this thing, you slide the filter to the entire image. This is what you get. Okay, normally this layer, the output of this convolutional, of course in the image processing we just call it the output image. Okay, normally we call it the output image, but in this class or in this course we don't call it output image. Okay, because later you will have more and more convolutional process, so that's why we don't use the output image. It's not suitable to be used that. We call it as an activation map. Okay, why is activation map? Because activation maps or actually activation map is referred to your O. In neural network is O, a matrix of O. Okay, this is your O. Okay, then don't get confused, because last lecture when I said to you that after you do the convolution to the entire image, you will get the matrix. Of course you will get the matrix there. It's a 3D matrix, which is the size is like this one, 28 times 28 times 1, but I call it as a net, the matrix of net. But in this discussion now I call it as O. Why I change it? Because in CNN, when you call it as a convolutional layer, okay, it's not just involve a convolutional operation. Yes, this one is a convolutional operation. Once you apply the convolutional operation, what you get here is net. And then if you slide to the entire image, you get a matrix of net. But for convolutional layer, it's also include with the activation function, meaning that this is your, of course this is what happened here is your when you execute with your input function. So once you apply the input function, that's why you get net. But at here where we don't have any picture here, actually there's a process here. Okay, but we by default we don't mention that. It's actually is an output function. I'm sorry, activation function. So once you get the matrix of net, you will execute or apply this matrix with activation function before you can get this activation map, where actually that's why I call this as a matrix of your O. It's not the matrix of your net. It's not a net matrix, it's a O matrix. Because in CNN, by default, what is the meaning by convolution layer is not just involve a convolution, which is this part. Okay, it also include with the activation function here. Once you get the output from the convolutional process, then you need to execute, or once you produce the convolutional or the net matrix over here, you must compute with activation function to get the matrix represent your O, which is called as activation map. So just make sure that you remember that when you call it convolutional layer, it's mean not just convolutional operation, it's also include with the activation function. So that's why activation map is referred to the O matrix. It's not a net matrix. Okay, because some also call this as a I think in some book they also activation map is also known as a feature maps. Okay, feature maps is also refer to this feature map is also meanings the O matrix. Okay, it's not a net matrix. Okay, that is only one filter. Okay, once you apply this filter, this is what you get. Of course, the number of that equal to 1 back, because in general, if you have a 3 times 3, if you are 3-dimensional, 5 times 5 times 3, if you convert with 32 times 32 times 3, then it will delay because the depth size is similar between the input image and the depth of filter here. So that's why when you do the convolution, you get 1 point. So it will end up into this 28 times 28 times 1. So why is 28 times 28? So if you remember that, okay, this one, if you have a 3 times 3 filter, then you will start at this point. You don't start at this point. So that's why you will end up only 2 times 2. Okay, because you ignore the pixels belong to this border, because you cannot proceed at this point because it will out of the boundary there. This out of boundary. If you don't proceed that, so that's why if you have filter with 3 times 3, will start here, because that is will make sure that everything here fit at this point. Okay. Again, if you, let's say I want to design this 5 times 5, so it will start here. Just assume this image is more and more bigger than this one. So if I have filter 5 times 5, then I must start here, because that is the only point. If you start, then you can fit all 5 times 5 around this point. Okay. So for the case of 5 times 5, you will ignore 2 pixels which is close to the border of the image or border of the matrix. If you using a filter with the size of 3 times 3, then you will start here. Then you will ignore all this point which is close to the all these pixels which is close to the border. So that is what happened. So if 3 times 3, then you start here. If you 5 times 5, you start here, meaning that you are ignore these 2 lines. So that is also happen to these convolutional layers. Why? Because you are using a 5 times 5, so that is why you will end up into 28 times 28. Okay, again 28, 32 minus 28 is what? It should be 4. So meaning that you are ignoring this 2 matrix which is close to border, and the other 2 is here. Okay, you ignore these 2, you ignore these 2, so that's why the total is 4. Or in other words, you are ignoring the 2 line of pixel which is close to border. So that's why it's the result here is equal, after you applying the convolutional operation, it will shrink up into 28 times 28. So of course, those who don't take image processing, I think you okay with this. But for those who take image processing, don't confuse, because during image processing class, I always said that the size should be similar, and then you just make it the one that is not processed equal to 0, 0, 0, 0, and you only proceed this point, and this point. But in CNN, it's a little bit different. If you apply the convolutional, you just don't draw this one. Okay, because when you have 4 times 4 input image, you are convolve with 3 times 3. The activation map should be output size should be 2 times 2. We just you just compute and get the point here, the point here, the point here, and the point here. But this one don't draw. This is only for CNN courses, okay? But for image processing courses, I want you to draw the same size, but this point must put 0, 0, 0, 0. Okay? So make sure that don't confuse, because now actually is a same convolutional process, but because in image processing I want to make sure that everybody get fundamentals or the simplest thing, the simplest way to understand the fundamental of image processing. I just by default we just set everything which is not processed with 0, and then we only count or calculate this one. But in CNN, yes, we not just ignore this one, we actually remove this one. That's why the output at this point is shrinking to 28 times 28. So for this example, if you want to talk about CNN, it should be 2 times 2 here, because now the 4 times power is shrinking into 2 times 2 because of you are using 3 times 3 filter. So I hope you clear. This is for CNN only. Okay, that is what happened when you are applying the convolutional process. If you have a 4 times 4, it will shrink into 2 times 2 because of because 3 times 3 only fit at this point. So that's why you will ignore the single line pixel which is close to the border. Then if you talk about 5 times 5, then you will ignore 2 line which is close to the border. So that's why in this case you ask, because you ignore a two line that is close to border. So this side you have 2, this side you have 2. So that's why you have the total, you have 4. So 32 minus 4 is 28. So that's how you get the result there. Okay, so that is how you compute from this input color image by using 5 times 5 times 3 filter. Again, the CNN is not just depend on one filter. Let's say you compute with another filter. Of course, this green is a second filter where the size is similar. In general, the size is similar. It might be the coefficient of the filter is different. The W inside here is different. Okay, but you are using that's why we put the color here as a green, just to make sure that it's not similar with this filter blue, because the coefficient is different from this green filter. So this is a second filter. You apply the same thing, then you get another 28 times 28 times 1, which is another layer. So this layer, activation map layer, is the output result from the second filter, while this one is the output result from this first filter. Okay, so that is what happened to convolutional layer. And then again, don't forget that here we have activation map. Activation function. That's why you get here is your O, is not your net. Your net is here, which is not draw, because in general when we talk about convolutional layer, is also include the convolutional process plus the activation function. So at the end, let's say you have a 6. This is what the meaning by channel or number of filter channel. So that's why I like I discussed before, I don't want to use the word channel at that point, because now channel actually in CNN is this one, channel or number of filter. So let's say you have if we had 6 5 times 5 filter, then you will get 6 separate activation function like this. If you realize that here they don't mention the depth. Even actually the filter is 5 times 5 times 3, but in general you don't mention the depth. So this is normal for those who discussing about the CNN. In general, we don't mention the depth because by default the depth will follow the depth of your input. So if the input depth is 3, then the depth of the filter is 3. So that's why we always don't write that one. So you only see like a 2D filter. It's not actually, in reality it's not a 2D filter, it's actually a 3D filter, because the Z dimension we don't mention in that, because automatically it will follow the size or the depth size of the input. Okay, so at the end, this is the activation that you get, or in other words, the activation map size here, or the matrix size of the activation map is a 28 times 28 times 6. Now the depth size of this activation map is 6. Okay, so we stack this up to get a new image of size. So this is the image. Of course, this is just so-called as an image. Of course, it's not image now because the depth is 6. Now it's not RGB anymore, it's more than RGB. So just assume now the size of the depth size is equal to 6. Okay, this one we have discussed before. So again, this is the animation show how the convolutional works in three-dimensional. Actually, it's a three-dimensional convolutional operation. So you can see that this is the input image R, G, and B, for example, and this is the first filter. This is the second filter. Okay, so you can see this is your 3 times 3 times 3. This one, in this example, they are using 3 times 3 times 3 because this 3 over here, okay, is follow this the depth size of the input image. So that's how you get this one, and then the second, this one for the second filter. Okay. Okay, this example, I just show you actually just as what happened at the convolutional layer. Sorry, what happened? Oh, okay, what happened at the convolutional layer? And again, this is just a one, just represent one layer only, meaning that if you want go towards these things, if you remember that example of CNN, yep, this one. Okay, you can see that what we discussed, convolutional layer, is referred to this layer, but that does not mean you cannot repeat the convolutional layer again. For example, in this overall cases there, you find out there's also convolution layer at this point, and again it will convolve between the filter here and the activation map or feature map around here. So if the depth size, can you see there what is the depth size of this feature map? 1, 2, 3, 4, 5. So the depth size is 5. Okay, the depth size is 5. So let's say you apply the convolutional 3 times 3 filter, 3 times 3 filter here at this convolutional process, then again it will be similar. You must provide a 3 times 3 times 5, because this one will follow the input depth. Okay, so and again, like I said before, normally in writing the filters characteristic, we always write this point, this part. We always delete this one, because normally by default we don't discuss this one, because by default this the Z size should similar to the Z size of the input here. So that's why when we write the filter, let's say what we write at the convolutional layer here is that we just said that what happened, we have a 6 3 times 3 filter. So what is the meaning by that? The number of filter is 6, meaning you have a 3 times 3 size filter, and then you have a 6 filter there. Means the total here you have a 6. This 1 2 3 up until 6 filter, which is the same size, 3 times 3, but we don't discuss about the this 5 element time 5. Okay, because normally we understand that this thing should be follow the size of the input. Okay, so that's why we don't write this one. So that this is the standard way in writing the characteristic of your convolutional layer.